Hey guys, welcome to lesson 6 on the true beauty of math, where now we're going to leave behind individual sets for a little while and start talking about functions between sets. Namely, we just learned enough about sets to derive the paradox, Russell's paradox, of lesson 5. So now let's start asking about what happens when we have more than one set around. What we're going to want to do is establish some kind of machinery to start talking about associations between elements in one set and elements in another set. Now, there are many ways to define such associations, and we're going to choose a particular one because it happens to be the most interesting of such definitions, and then we're going to study that for the next several lessons. So, in particular, suppose we have some set A equals 1, 2, 3, and some set B, which equals A, B, and C. These are sort of our standard examples of sets. Although we know at this point that we can define some really crazy, wacky sets, and there's no reason why we couldn't consider those here. What we want to do is find some way of relating the elements in A to the elements in B. Again, there are many different ways that we can do this, and we're going to choose one such way. This is just a definition. Let me write the elements in A as follows, and the elements in B as follows. A here and B here. And let's just draw arrows from elements in A to elements in B. Now, the motivation for this might be as follows. Suppose I have a set of apples and a set of baskets. We want some notion of being able to determine when certain apples are in certain baskets. And then we're just generalizing this to some pair of generic sets at all, namely associating elements in one set to elements in another set. In this case, we've associated 1 in A to B in capital B, 2 in A to lowercase a in B, and 3 in A to lowercase c in capital B. This is just one particular association. Now, the requirements that we're going to ask of a function is to send every element in A to some element in B. Namely, because we're drawing arrows in a particular direction, we've singled out a set as the from set and a set as the to set. Namely, associations are going from elements in A to elements in B. And what we're going to require is that every element in the from set gets sent somewhere in B, and also that every element in A gets sent to only one element in B. So for example, the function from A to B, or the assignments from A to B given as follows, would not be OK. Because, so let's consider this set of assignments. 1 is associated to A and to B, 2 is associated to B, and 3 is associated to nothing. This is problematic for two reasons. One, 3 is associated to nothing, as I just said. And the definition of a function that we're going to go with is that every element in the from set needs to go somewhere in the to set. This is problematic for a second reason, because we're also just defining a function to be something such that every element in the from set gets sent to only one element in the to set. Here we see that 1 is sent to both A and B, and that's not OK. It just doesn't satisfy what we're calling a function, and therefore this cannot be a function at all. And so again, a function is just something that sends every element in A to something in B, and every element in A to only one thing in B. So as another example of a function, we have 1, 2, 3, A, B, C. We can send 1 to A, 2 to B, and 3 to B as well. Now, C in B is not hit by anything. C in the set B is not hit by anything in A, but that's entirely OK. Everything in A is sent somewhere, and every element in A is sent to only one element in B, and so this is a perfectly good function. There are more general definitions of functions between more general sets, and we give those in the written lesson, but this gives the gist of what a function is all about. In the next lesson, we're going to start studying special kinds of functions where maybe it is the case that every element in B gets hit by something in A, and some other requirements that we could ask for a function. But in general, a function is just some association of elements in one set to elements in another set, such that every element in the from set gets sent somewhere in the to set and gets sent to only one place in the to set. We give even more detail, more examples, and more insight into functions and why we want to consider functions in the written lesson, which is either given below or linked to below if you're watching this on YouTube. And for even more details than that, you can check out the True Beauty of Math Volume 1, where we also give exercises with full solutions and even more details about everything that we just talked about here. Once we are comfortable with all of these things about functions, I'll see you in Lesson 7, where we'll start talking about special kinds of functions. I'll see you there.